welcome you to this presentation on identification of city hotspot by analyzing telecom CDR using complex network modeling. I am Dr. Giridhar Maji, academic editor +1, and this work is done during my PhD under the guidance of Dr. Somo Sen, assistant professor at CSIT. Now, the whole work, that is identification of city hotspot, is divided into 4 parts. The first part is collecting the raw data, CDR data, that is telecom call detail record, where various details like source cell ID, that is where from the call is made, to destination cell ID, where to call is made, and interaction, that is the amount of call, the duration, call duration, or SMS or internet access, etc. So we get the raw data, then we do some kind of pre-processing to create, like we divide the city into smaller grid cells, and then we aggregate the CDR activities spatially as well as temporally. So we get, then finally we get a network. We model this CDR as a network where the nodes are the city grids are the nodes and the interaction is the edge weights. Then finally we employ the edge weight degree decomposition technique, that is from complex network domain, the centrality algorithm to the network, and to identify the city. So the data is something like this. These are the city. City is divided into smaller grids, and for each grid has a unique ID. From one grid to another grid, this is the amount of telecom activity. So this becomes one node, this becomes one node, and this becomes the edge weight between edge. So if there is interaction, there is edge. There is no interaction, there is no. Then we actually do some kind of pre-processing, the edge weight based thresholding, to reduce the network size from the dense network to sparse network. Then we employ our EWDN method. This method is actually proposed by us and in some other work, and then we employed that method to this model networks to identify the city hotspot. In this method, what we have done, we have actually first find the edge weight degree of a node, of each node. This edge weight degree is calculated using the node degree and some formulation. This formulation actually is iterates over the all neighborhood edge weights and then create the edge weight degree. So this alpha is an empirical parameter taken as 0.5. So once we get this edge weight degree, then what we do the KSL type of iterative decomposition, and then as we in a similar way to KSL index, we get a edge weight index, KSJ. For then this value, then for each node, once we get all these values, iterative values, then we iterate over the first order neighborhood to get the final score, and based on this final score, we rank the nodes. Now for this Milan, we have actually 10,000 grids, and out of 10,000 grids, we have identified top 50 nodes, that is top 50 places. Then we mark this in red, the places identified by our algorithm. So this is Milan Sunday, this is Milan Monday. Similarly, this is train to Sunday, and this is train to Monday. And we see that the important places are different in Sunday and in week, that is on weekend, and on weekdays, the important places are different. And after that, what we have done, we have placed it on the very map, and then we can the ground truth that our identified areas are these areas, and these are the a square 85060 is city center of Milan, and we see that our algorithm identified it as an important place. Out of 10,000, we have identified only 50, and we see that all the important places come within this 50. So we see that our algorithm actually in real time, it can provide identify the important places in a city, and this has many real life applications. Like it can be used by the city administrator for different kind of emergency provisioning. They can identify the changing pattern of the city dynamics, like which new places becomes hotspot and which places becomes obsolete. So for details, you can see the paper, and thank you for listening.